Hello guys, I'm back. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. And today I am here with you to share a little bit of my work as a chemical process engineer in plant design doing preliminaries P&ID. Right now I am working in a project and I need to develop preliminary P&IDs to issue for the detailing engineering company. And here I have a compressor, and what I would like to share with you in this video is a specific point related to the details. How aware you must be of your process in order that you put the lines in the correct position. So you can see here that in this drawing I have the compressor, I have the discharge of the compressor that goes to the gas grid. I have an isolation valve, check valve, and a manual isolation valve, and I have a tap for the analyzer. And this step of for the analyzer is upstream of the line to the flare. And why I did that? This is a very important thing because eventually you can decide to install this line, for instance, downstream of the flare tap, for instance. Let me just move this. For instance, what happens if I install the tap for analysis downstream of the valve for flare? What will happen? Imagine that in normal operations or when the plant is shut down, all the isolation valves will be closed. So in this case, I will close the suction, I will close the discharge, and when I start the plant, what is usual is that I will open the inlet and I will start the compressor in a recirculating mode because I must guarantee the quality of the product before feeding that to the customer. That is the gas grid. And the way that I have to verify the quality of the natural gas to the gas grid is getting samples to my chromatography, for instance. And what will happen if I add the tap downstream of the valve for flare? When I am doing the purification of the gas, I will run my compressor and I will open the valve for flare in order that I have flow, and with that I can adjust my process to get the purity of the product. And if I add the tap of my analyzer downstream of this line to the flare, I will have a dead space here. The analyzer gets a very small flow to do the samples and analysis of the stream, and as at this point is a dead end, I will take much more time to have a new sample for my chromatography if instead of doing that I just add my tab for upstream of the flare valve, because this way when I run the compressor and I'm sending the gas to the flare, I am renewing in online mode the sample for my chromatography. Of course that the chromatography, the run of a chromatography depends on its settings, but at least at this point here, I don't have a dead end. I have a flow going through with the current composition of my gas. So when you are drawing a P&ID, a pipe instrumentation diagram, this is a representation of the real installation of your process, and the pipe engineer or the designer, the piping designer, will most often they will not think about the process. They are not paid. It is not their work to think if your tap is in the correct position or not. So when they get the pipe instrumentation diagram and see the tap downstream of your control valve, they will design the system as it is in the pipe instrumentation diagram. So to avoid this kind of mistake, you must be aware of it and place the tap in the correct position. So with that, the chances are that you will be able to feed the customer much faster than if you just add the tap downstream of the flare valve. So guys, if you like this video, share with your colleagues, chemical process engineers and chemical process engineers groups, because this way you'll help me to achieve 100,000 chemical process engineers around the world. So guys, this is it. I hope you like it and I'll see you soon in the next video. Bye bye.